If you start machine learning by importing libraries and calling .fit, you are not learning machine learning. You are memorizing rituals. That's why most machine learning models fail outside notebooks. They don't fail because the algorithm is weak. They fail because the person training them never understood what algorithm was actually optimized. In this video, I'll break one illusion: what training really means, what an ML algorithm actually is, why raw data silently destroy models, and why pipelines aren't optional, they are mandate. This isn't a tutorial, it's a logic behind entire machine learning pipeline. Model training is not learning patterns, it is solving an optimization problem. In any model training pipeline, you are given an input feature X, a target Y, and a loss function. Model training means only one thing: find parameter values that minimize numerical error defined by the loss function. That's it. The model does not understand meaning, the context, and the correctness. It only knows one signal. Does this number goes down? If your loss function is poorly defined, the model will still optimize. It will just optimize the wrong objective. An ML algorithm is not a black box. Every ML algorithm, without exception, has three components: a loss function, an optimization strategy, and a set of assumptions. If you don't understand all of three, you don't understand the algorithm. So, first is loss function. It defines what does wrong cost. The loss function defines how expensive a mistake is. For example, regression defines the distance between predicted and actual value, while classification calculates penalty for incorrect probabilities. The model does not know what is correct. It only sees number produced by the loss functions. So, if you don't define the loss function, there will be no direction, ultimately no learning. Optimization strategy. In optimization strategy, the thing is, how does the model move? Optimization answers one question: how should parameter change to reduce loss? In typical loop of optimization strategy, first thing we discuss is slightly change the parameters, then measure loss, move in the direction that decreases it. This process is blind. Gradient descent doesn't know the truth, it only knows the downhill. Assumptions. Assumptions are considered as an invisible cage. This is where most learners fail. Every algorithm restricts the patterns it wants to present. For example, linear model assumes linear relationship. Distance-based model assume distance are meaningful. Tree model assume separable threshold-based splits. An algorithm cannot violate its assumptions, no matter how much data you give it. If your model violates these assumptions, optimization still happens, convergence still occurs, and the result looks strange, but it's wrong. The model doesn't crash, it lies confidently. Why raw data breaks model? Raw data comes from the real world. Algorithms operate in mathematical space. By default, raw data violates assumption. For example, scale distortion means if one feature ranges from 0 to lakhs and the other ranges from 0 to 100, the optimizer assumes the larger numbers matter more, even if they don't. That's not intelligence, that's bias. Let's see another example about categorical data. Models can't understand words. If you import red equals 1 and blue equals 2, you told the model that blue is greater than red. The relationship is false, but the math accepts it. The last part of this video is about the importance of pipelines. Why pipelines exist. Machine learning pipeline enforce discipline. It guarantees identical transformation during training and inference, preservation of algorithm assumptions, prevention of data leakage, reproducibility. Pipelines are not convenience tools, they are structural requirement for valid optimization. No pipeline, no trust in your model. Machine learning works only when optimization is clearly defined, assumptions are respected, and data is transformed consistently. Before tuning models or including features, you must understand how algorithms interpret numbers. The reason of diving into these initials before starting the hands-on with machine learning is that you need to understand the algorithm working and the underhook work of machine learning. If you don't understand these things, every model you train is just trial and error, and you should never understand why they succeed or fail. In next video, we'll break down how analyze data through the lens of algorithmic assumptions. Follow AI TechMist for more tech updates and videos.